Today we are going to see about the CA MAT CICS Callstack functionality. So with this new feature in Math, we provide, thank you. And with this new feature Callstack functionality, we provide a list of programs, their transaction issues, and its call count, and the elapsed time. So let's see first how we calculate the elapsed time on this particular feature. So let's say a program which a transaction 1 issues a 5 programs, and program 1 calls 2, program 2 calls 3, and so on, and the program file returns to program 4, and program 4 returns to program 3, and so on. So for this particular scenario, we calculate the elapsed time like for the program 1 when it is invoked and when it has ended. And let's say if you want to calculate the elapsed time of program 3, the elapsed when it has started and when it is returned to the program 2. So this is how we calculate the elapsed time of this particular feature, and we support all the IBM supported transfer control for this new functionality. And then let's see the reason for implementing a call stack. So the nature of the sampling is like we might not be able to capture all the programs in the measurement. Let's say during the 10 millisecond, a program run within 10 millisecond, so it cannot be captured, and it is not required because it's effective and its performance is good. And one more reason is it's a customer need. So let's see some of the tuning opportunities why we are implementing this call stack. So the first one is the legacy issue. Let's say the application issues more than 50 programs, and it's took time to see what are the list of programs and how many times it's called is in manually is very difficult. And we provide the opportunity with the call stack within a measurement. We can see like how many programs are called by that particular transaction and its call count and elapsed time. And then the load module only. Suppose the application is created a very long back, like 20 years before or some, and we have only the load modules only, and we do not know how many programs are issued by a transaction and kickstock. With CICS call stack, we can find it. And we can see the tuning of a program with call stack with some demo now. And before starting a demo, I just wanted to explain, like we have created a small program only for this demo functionality. It's a very short program. So we have a transaction called KLTX and issues 5 programs like KLTX1, KLTX2 to 5. So this program KLTX1 issues KLTX2 100 times as a call count, and this KLTX2 calls KLTX3, 4, 5, and it returns accordingly to 4, 3, 2, and 1. So let's see a live demo now. So here I have 2 profiles with calls 1 and calls 2 to see how we can tune with this CICS call stack. So with the call 1, the measurement has made, and when we try to analyze this, and in the tran view, we can see the transaction captured and its CPU time, response time, and other details. With this, we have introduced a new line command called CS, a call stack. So with this call stack, if we issue the line command here on this particular transaction, we can see this KLTX1 has called once, and KLTX2 has called 100 times, and other program has called 1 time with the elapsed time of details of elapsed time here. And we can see this particular program has called 100 times, and if there is any issue with this program, we can go to the code view, and in code view we can see there is a lot of CPU consumption made by the KLTX2, and when we try to analyze the histogram with this, you can see there is a particular instruction MVC which has consumed a lot of CPU. And I have already registered the listing here, and if you look at the listing, see there is a particular label called loop2, and which is executing multiple times, and there is a MVC instruction here which just moved test to test 2 with multiple times. So it indicates that this particular measurement indicates that there is some performance issue with this MVC. So I have moved this MVC2 out of the loop and made another measurement. So we can see how it has improved our elapsed time as well as the CPU. In the tran view, the option 6 with tran view, we can see the total CPU time has drastically reduced from 19 to 9. And when we look at the call stack option, we can see the KLTX2 has called 100 counts and the elapsed time has reduced drastically. And we look at in code view, we can see the most conscription came out from KLTX to KLTX4 now because of its nature. We have created like that. And if you look at this particular KLTX2 histogram, we can see there is no move instruction consuming more as if you, sorry, there is not listing registered. So if I register the listing with it is in PDS, I'm adding the new listing now. Uh, program name KLTX2. So the new registering is added and it's successfully registered. So if I look at the listing now, we can see the MVC is moved out of the loop. So, and it is showing the measure, the performance has more, the consumption has more inside this loop. And we can see there is a reduction of CPU time as well as elapsed time. Yeah, that's it from me.